Hi and welcome to this ORICtober video, a celebration of the Oric 1 computers from the 1980s in October 2021. Before I start with the topic of this video, I wanted to give a massive shout out to the Centre for Computing History in Cambridge. This weekend, 9th and 10th of October, they held the Retro Computer Festival, which was brilliantly attended with loads of fantastic volunteers and exhibitors showing computers from back in the day and even from before back in the day in terms of my experience. Everybody was so friendly and knowledgeable and enthusiastic. It was a great weekend, really enjoyed myself, met a few people that I've been following on Twitter and they were all lovely. So thank you all for making the festival a brilliant one and look forward to the next one. And I hope that everyone is following the Centre for Computing History. On Twitter, they are at Computer Museum. I really do recommend that if you're interested in old computers that you give them a follow. So what's the topic for today's video? Well, I was speaking with a Twitter friend of mine at Sheila Dixon and met her in real life at the computer festival, and I was explaining to her that I thought that I should do something which is not just loading games and showing games, but talking about the Oric and showing some of its features and capabilities, and she agreed, and so this video will be a little bit about what the Oric is and its features, rather than just playing games. I will actually come back to that because we've got plenty of time in October to look at some more software. So let's talk about the Oric itself. It's a 6502 machine. This is the same CPU, 8-bit CPU that you'll find in the BBC Micro, or the Apple II, or the Commodore 64, or the Atari 800 XL, which is another computer I owned back in the 80s and one of my favourite computers. And there's many others. There's VIC-20, there's well, of course, the Apple series, Apple I as well as well, what other computers were there with 6502? Quite a few actually. It was because it was a low-cost CPU back in the mid to late 70s. It came out, and it was much cheaper than other 8-bit CPUs that came out. So it became popular for home micros back in the day. The other CPU, of course, that was very popular was the Z80. And that was powering computers like the Spectrum and the MSX range of computers. So that's the Oric's CPU at the heart of it. And then there was the uncommitted logic array, which gave us a text mode of 40 by 28 columns, which is what we can see here. And in a high resolution mode of 240 by 200 pixels. And that's the basic display capabilities of the Oric, plus 8 colours. So we can have a look at those colours in a minute. The other thing that the Oric had was a separate sound chip. So unlike the original Spectrum's little beeper, which had to be powered by the CPU, the Oric had a General Instruments AY38912 sound chip, which gives you 3 tone channels, which can be all mixed with some white noise to get other effects, but also an automatic or driven by the sound chip envelope. And now envelopes are a way of changing the sound that's coming out without the CPU, the 6502, intervening. So it means that you could play sounds which didn't require the processor to be tied up playing the sound. It could do something else. And of course, we'll all know that the Oric had some famous sounds like zap, shoot, explode. I love that one. And ping. And beyond that, there were commands to make specific sounds of your own design. And I'll go into that later, maybe in a separate video, because I want to keep these videos less than 10 minutes if I can, Otherwise I keep going on and on. So what I want to do though quickly is go and talk about the kind of graphics, the text and the high-res modes I just mentioned. So if I before I clear the screen, there are 8 colors as I mentioned. There are commands in BASIC to change the color. The foreground color is changed by the command called ink, and the background by a command called paper. So let me just go through some of the colors. Ink 0 is already black. That's what we can see. Ink 1 is red. So you can see, I think you can just see that it's turned red on the webcam. Ink 2 is green. Ink 3 is red plus green, which makes yellow. Ink 4 is blue. Ink 5 is blue plus red, 1 plus 4, which is magenta. And then it doesn't look very magenta on the webcam, but it is quite pink when I look at it on the screen here. And ink 6 is 4 plus 2, which is actually green plus blue, which is cyan. And I won't do ink 7 because ink 7 is white and you won't be able to see anything. So those are the 8 colours that you can select for the Oric. And the way the Oric displays colours is through an interesting feature called serial attributes. Now, serial attributes have the property of essentially taking a character position on the screen and deciding whether the code at that position should be treated as a character that needs displaying, for example, the S in serial attributes, or whether the code should be a command that applies some kind of effect. And essentially in the Oric, any code that is less than 32, and if you know your ASCII, then you know that 32 is space in ASCII. So anything less than 32 is treated as a control character rather than a display character. And that control character, for example, can do something like change the color of the screen, of either the foreground or the background. And in fact, that's one of the reasons why you always get 2 blank columns to the left of the text. These 2 blank columns are not actually blank. One of the columns is telling the Oric that the background should be white, so that's the first column, column 0. And then the second column is telling the Oric that the foreground should be black. And the advantage of this is that in the same screen, you don't need a separate area of RAM to store your color codes for each position on the screen. You can just issue a command at a particular position, and that command will be in effect until the end of the line, and then the Oric resets back to a default of white text and black background on the next line. So it's very efficient. The big disadvantage is that where you've got a control code, you can't also display a character, which is why we have these 2 blank columns on the left. And so the 40 column screen we've got is actually only 38 usable columns. So that's one of the disadvantages. But let me bring that to life and show you how it works. The Oric has the screen starts at 48,000. Now, if I just bring up the caps lock, you can see that the Oric starts at 48,000. That's the very top left. There's 28 rows, but the very first row is used by the system for status messages and the like. So in normal BASIC, you can only use the 27 rows. But the very top left, if I was to put, say, ASCII code 65, that's treated as a displayable character, which is A, if you know your ASCII. However, if I do a code less than 32, I'll get something else. I'll be issuing a command. Let's say I want to change the background to red. Well, I know that's code 17 on the Oric, and you should be able to see there that the background has turned to red, and it's in effect for the rest of the line until the next line. And in fact, on the next line there is a code already set to set the background to white. Now, what if I wanted to set the next cell to green? So the next position I could set to 18, which I know is green, and that will give me a background of green. So that's nice. I'm not using up extra RAM anywhere else to do that. However, I can't display a character in position 48,000. It's a code saying have a red background, and in fact even I can't even change the foreground color without adding another command. So if I went on the position after the green and set, for example, let's say I wanted to have a blue foreground, I've already set the background blue foreground, which I know is code 4, then well, you can't see it because the caps changes the foreground back to white. But if I put a character in 48,003, let's say 65 again, you can see that's blue. So the problem is it's efficient, but it takes screen real estate up to switch colors, foreground and background. Now the problem for that is in doing high color animations, it can become very tricky. However, programmers who are adept at manipulating the Oric's palette got really good at hiding this effect and minimizing the what looks like a blank screens and blank characters on the screen quite effectively. So I can maybe explain some of that in some of the future games I show, but it's amazing what programmers managed to do even though there were these constraints. Now, what does Oric allow you to do in high resolution mode? If I type high res, it will take me into high res mode, and I've got 3 lines of text, but I've got this black space above me, which is a 240 by 200 pixel screen. And it's got high level commands like curset is setting the cursor at whatever position I want. And I'm going to hit the middle of the screen. And then I have also commands like circle available to me, and that will draw a circle 80 pixels radius. Also, it has a draw command, which is uses relative coordinates to wherever the cursor is. So if I went 50, 51, that's going to draw a diagonal line down. And if I then the cursor is moved to the end of that line. So if I move minus 50, it will draw a straight line because it didn't go up or down. And then if I do minus 50 on the y-axis, you can see what it's going to do. So it's a little bit logo-like in terms of the high-res commands. So that's in high-res. There are a few other commands which I'm not going to go into because I'm already over 13 minutes, and I really know that that's getting too long to expect people to watch a video of me rambling and typing some basic commands in. But I hope it gives you a feel for the graphics, and I just showed you a little bit of the sound, but I will go into a little bit more detail on some of the graphics commands, some of the sound commands, so you get a better idea of what you can do with the Oric out of the box using BASIC. I'm not yet going to go into machine code or any other little tricks to exploit the Oric's ULA, as I mentioned some programmers have. But we're already way over 13 minutes, so if you got this far, thank you very much for listening, and see you on the next video. And in the meantime, please drop a comment out. What would you like to see or hear about the Oric? And I'll do my best to accommodate it as part of the rest of ORICtober. Thank you very much. Bye-bye.